Hello and welcome. We have been discussing about the states of matter. I hope you are following the lectures. So today we got to discuss about the change of states of matter. So basically we know that we will be discussing about only the three states of matter, that is solid, liquid and gas. We have already differentiated about it and talked about it in quite details in the previous lecture. So today's discussion is basically based on the change of states. We know, isn't it? Water can be converted to ice can be converted to water, so on and so forth. Okay, so how does that conversion takes place and why does that conversion take place? Okay, what is the mechanism behind it? Okay, for example, if we heat a solid, so if we keep on heating it, it will get transformed into liquid, and if we keep on heating a liquid, it will get transformed into a gas. Similarly, taking it the vice versa, if you cool a gas, it may be converted to a liquid, and if you cool the liquid, it may be converted to a solid. Okay, that is it. That everyone knows. Heating a solid gives you liquid. Further heating gives you gas. Cooling a gas gives you liquid, and further cooling gives you solid. Isn't it? That's how you prepare ice creams, isn't it? In your homes, you use your refrigerators. Okay, so basically. What happens is when you heat, okay, when you heat, you are increasing the temperature, right? You are increasing the temperature. So if you increase the temperature, what happens is what we have said is the particles in a solid are tightly packed with one another, isn't it? So when you heat it, what happens is as we have said, the particles are in constant random motion. These particles get excited because their kinetic energy increases. Energy and temperature are related directly. So if we increase the temperature, these molecules, the movement of the molecules becomes more and more random, and the excitation level becomes such that these particles they get separated, and they may take this form, that is analogous to that of a liquid. So you can see those particles which are tightly packed, on increasing the temperature, they acquire a greater kinetic energy as a result of the excitation of the particles. The interparticle distance gets separated, and it gets converted into a liquid. It's very simple, and the same theory, the same concept can be applied when we are converting a liquid to a gas, isn't it? Once we increase the temperature, the particles get excited, the kinetic energy of these particles increases, so the interatomic separation distance, interparticle separation between here in case of liquids gets more and more, so it gets transformed into a gas. So basically the interparticle forces of attraction are overcome if we increase the temperature more and more, and that is how solid gets converted to liquid and liquid gets converted into gas, and vice versa. If you cool it, the same thing may happen. If you keep cooling it, the particles may again acquire the interparticle distance may again decrease, because the kinetic energy decreases in that case, isn't it? So this gas can be converted into liquid, and the liquid can be converted into solid. Okay, so basically increasing the temperature means increasing the kinetic energy. So increasing the kinetic energy means these particles are getting excited more and more, and a point is reached where this arrangement of particles acquire some sort of this sort of arrangement, and this is where we are changing the state from solid to liquid, and maybe from liquid to gas, and so on. Okay, so basically temperature is a very major factor which is responsible for the change of state of matter. Okay, so here I have tried to express the interconversion of states in the form in some sort of a flow chart. Okay, so if a solid is converted to liquid, the process is called fusion, and if a liquid is converted to solid, it is called solidification. Similarly, if liquid is converted to gas, it is called vaporization, and if a gas is converted to liquid, it is called condensation. Okay, if it is directly converted to gas, it is called sublimation, and if a gas is converted to solid, it is called deposition. Now there's no meaning to mock these things. Okay, if you understand, it's very simple. Okay, now what I'm trying to say is, I have already explained how this concept of temperature is working. Okay, now what happens actually is the states of matter, they change, right? So this is a very interesting point. Now what happens is, if we take ice, okay, if we take ice is solid obviously. If you take ice and you start heating it, okay, start heating it, the particles get excited, the kinetic energy increases, and there exists a certain temperature at which this solid becomes liquid. Are you understanding? The temperature at which these particles get separated in such a way, the interparticle distance is separated, is increased in such a way that this solid acquires a liquid configuration. That temperature is called the temperature. So what we have known is the transformation of the states may take place. Now, if you take ice, okay, in a beaker, and if you start heating it, if you take ice in a beaker and if you start heating it, what happens? Slowly and steadily, this arrangement of the ice is solid, isn't it? The interparticle distance will start to increase due to thermal excitations, isn't it? Because the kinetic energy of the particles will increase. So a point will be reached at which this solid gets converted into liquid. That is, that ice will start getting converted into liquid water, isn't it? So that point is called melting point, isn't it? So how much amount of heat is required to convert that solid into liquid, that is ice into liquid, is called latent heat. Now that is the minimum amount of heat required. Now what is happening basically is, when you are heating a solid, and the temperature at which this process takes place, the solid gets converted into liquid, that temperature is called melting point, right? Melting point, which is basically 0 degrees Celsius, isn't it? So when you are heating ice which is placed in a beaker, what is happening? If we start heating it, the temperature of the ice will not increase. So where is the heat going? The heat which you are providing from outside, where is the heat going? That heat is being used up to convert this solid into liquid. That heat is being used up to convert the ice into the water. Okay, so that ice is being converted into water, and the heat which you are supplying is used in that. So the contents, that is the beaker, gets heated up, isn't it? The beaker gets heated up, but mind you, the temperature of ice remains the same. We are not increasing the temperature of ice. Are you understanding? And that heat is hidden within the contents of the beaker. Okay, so that is why that heat is sometimes called hidden heat. Okay, and that heat is called latent heat. So you must have known latent heat is hidden heat. Okay, so hope that so basically, in simple words, latent heat is the amount of heat required to change the state of matter from one state to another. It's very simple, and it is when you start heating a substance, the temperature of the substance doesn't increase, but that heat which you are supplying from an external source is being used up to convert the change in state, which is seen by in this example of heating of ice, which is seen by where we can feel the heat, where we can feel that the beaker is getting heated up. Okay, so that heat is being hidden in the beaker, so that is called hidden heat, which is technically termed as latent heat. Okay, similarly, the temperature at which the liquid gets the amount of heat required to convert a liquid to a gas is called latent heat of vaporization. The amount of heat required to convert gas into liquid is called latent heat of condensation, so on and so forth. So latent heat is the heat required to change the state. Now there is another very, very important point which you need to understand. Effect of temperature you understood. Now we will discuss about the effect of pressure. Now what happens is, these are pressure and temperature are the two parameters which are used to determine the state of a substance. Okay, have you ever heard about solid carbon dioxide? Basically, carbon dioxide is a gas, right? So solid carbon dioxide means carbon dioxide which is stored at a very, very high pressure. Now what I am trying to say is, this gas, if I keep on increasing, carbon dioxide is a gas, so if you keep on pressing it, if you apply more and more pressure, so these molecules, these particles, they try to converge with one another and form a compact structure, because you are applying more and more pressure to it, isn't it? So in that case, this carbon dioxide is becoming solid, and that is called solid carbon dioxide. It is also sometimes called dry ice. Okay, now what happens is, if we decrease the pressure, in such a way that this gas directly solid carbon dioxide gets directly converted into gas, okay, that process is called sublimation. So if you keep on decreasing the pressure, a situation may arise where this solid carbon dioxide, okay, which is stored under high pressure, may get directly converted into gas. That process is called sublimation, and the heat which is I have already talked about temperature, and now I am trying to explain the effect of pressure, how pressure works. Okay, so temperature and pressure, these are the two essential parameters which are required to specify the state of matter. Okay, and those parameters describe the transformation from one state to another. So these are the concepts which we need to know, and hopefully this lecture is clear to you all. In the next class, we'll continue with the chapter. So till then, see you, stay safe.